Hello everyone, my name is V. Dinesh and my topic is types of addressing modes. Addressing modes specify the way the effective address of an operand is represented in the instruction. Some addressing mode efficiently allows referring to a large range of area like a linear array of addresses and list of addresses. Addressing mode describes a flexible and efficient way to define complex effective address. Generally, the programs are written in a high-level language as it is a convenient way to define the variables and operations that the programmer needs to perform on the variables. Later, this program is compiled to generate the machine code. The machine code adds low-level instructions. The low-level instruction has opcode and operands. The addressing mode has nothing to do with the opcode part. It focuses on presenting the operands addresses in the instruction. Types of addressing modes: register addressing mode and direct addressing mode, immediate addressing mode, register indirect addressing mode, index addressing mode, auto increment mode, auto decrement mode, and relative addressing mode. Effective address EA. Effective address is the address of the exact memory location where the value of operand is present. And the first one addressing mode is register addressing mode. Every instruction includes operands. The operands can be a memory location, a processor register, or an input or output device. The instruction which uses processor registers to represent operands is the instruction in register addressing mode. Here, the effective address is a register where the value of operand is present. EA is equal to R. Below, we have two instructions as our examples for register addressing mode. Add R4, R3 and load R3, R2. In the examples above, the add instruction uses registers, registers to represent both of its operands. Similarly, the load instruction also uses registers to represent both of its operands. So the instruction above uses register addressing mode to describe the address of the operand. Below, we have a figure showing the add instruction in the example above. In this, we can see that uh, operand 1 is R4 is stored and operand 2 R3 is stored in processor registers. And the advantage is in the register addressing mode, there are no memory references as the value to be operated is present in the register. Disadvantages is registers have limited address space, so it has limit on the size of value that can be stored. Direct addressing mode. The direct addressing mode is also known as absolute addressing mode. Here, the instruction contains the address of the location in memory where the value of the operand is stored. Here the effective address is the address of the memory location. EA is equal to A. For example, observe the examples below. Add R2, A, store R2, B. The add instruction includes the memory location A, which has a value to be added to the content of register R2. Similarly, the store instruction has the address of memory location B, where the content of register R2 will be stored. Below, we have a figure showing the direct addressing of the operand A in the add instruction of the example above. As you can see that direct addressing of operand is shown. Advantage is direct addressing mode is the simplest of all addressing mode, and disadvantage is direct addressing mode provides a limited address space. And third one is immediate addressing mode. In immediate addressing mode, the value of the operand is explicitly mentioned in the instruction. Here, effective address is not required as the operand is explicitly defined in the instruction. Let us see the example of immediate addressing mode. Add R2, R2, hash 100, store R2, 100H. And in the given figure, we can see that immediate addressing of operand 1 R2 is stored and operand 2 100H is stored in CPU memory. Operand 1 R2 is stored in processor registers. Fourth one is register indirect addressing mode. A processor register is used to hold address of a memory location where the operand is placed. This addressing mode allows executing the same set of instructions for a different memory location. This can be done by incrementing the content of register, thereby pointing the new location each time. In higher level language, it is referred to as pointers. The indirect mode is denoted by placing a register inside the parenthesis. Here, the effective address is the content of memory location present in the register. EA is equal to R. Now, for example, load R3, R2 and load load R2, A. The load instruction above will load the value present at the memory location contained by register R2 in the register R3. The figure below shows how the register R3 gets loaded with the value stored in the memory location held by register 2. And in the given picture, we can see that indirect addressing of operand. Operand 1 R3 is stored in processor register and operand 2 R2 is stored in processor register and CPU memory, and the value of the CPU memory is transferred to processor register. Advantage is in the register indirect addressing mode, the same set of instructions can be used multiple times. And disadvantage is in the register indirect addressing mode, the number of memory references is more. And the fifth one is index addressing mode. Index excuse me. Index addressing mode is helpful when the instructions in the program are accessing the array or the large range of memory addresses. In this mode, the effective address is generated by adding a constant to the register's content. The content of the register does not change. The symbolic representation of index addressing mode is denoted as x of r, and the effective address is denoted by EA is equal to x plus r. And the given picture, we can see that operand 1 Ri is, is stored in many forms, and the values are stored in register R3, R4, R5, R6. Operand 2 x of R2 is stored in particular register R2A. And the sixth one is auto increment addressing mode. In auto increment addressing mode, once the content of register is accessed by the instruction, the register's content is incremented to refer to the next operand. Symbolically, it is represented as below R plus. Here, excuse me, sorry. Here, the effective address is content of the register as it is closed by parenthesis. The content of register, which is referring to a memory location, is incremented so that it could point the next memory location where the next operand is stored. Auto decrement addressing mode. It is just opposite of auto increment mode. In auto decrement mode, the content of the register is decremented initially, and then the decremented content of the register is used as effective address. Symbolically, it is represented as minus of r. The auto increment and decrement mode help to implement a stack structure. And the eighth one is relative addressing mode. In the content above, we have discussed the index addressing mode. There we were adding a constant to the register content to refer the next operand address. In some computer, instead of a register, the program counter is used. The symbolic representation of relative addressing mode is x of PC. The effective address for it would be EA is equal to x plus PC, as here the operand addresses are found relative to the program counter. That's why it is referred to as relative addressing mode. Advantage is relative addressing mode doesn't require memory references, and disadvantage is relative addressing mode doesn't have any disadvantage as such. Thank you, everyone.